today is Chapter 4, Lesson 1. So we're going to continue and we're going to go on to Chapter 4. After Chapter 4, we're going to come back to 1 and 2. Okay? Today is Terminating and Repeating Decimals. There's a lot of information today. Okay? A lot of information. So make sure you're getting at least an example down so you can look back at your notes and so you can figure out what you need to do in your homework today. Okay? So my bell ringer, how do you divide decimals? Yeah, Cadence. Okay, hold on. 10.2 divided by 5. Okay. 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 Right? Okay. Okay. Very good. Very good. Okay, now what if I have Jasmine? What was it? By 4, 5? Oh, 0.45. Okay, I gotcha. Okay, so I'm going to stop. You're going to move the decimal over here, right? 2 spaces, correct? Yep. 1, 2. Yes, you also have to do that on the next one. 2 spaces, and then your decimal ends up here. And then you divide like normal. Very good. One thing you cannot forget today is to put that decimal up. Just remember, Cadence said you put it up on top. This is what I would do if I were you. As soon as I see that decimal and I have where it's going, I would put it directly on top. That would be the first thing I would do. Because otherwise, you're going to forget it. It's going to go in the wrong spot. Put it up first. Okay, we'll do some examples here in a second. So, all right, so if I were you in your notebook, I would write this. To convert a decimal to a fraction. Okay, because that's the first thing we're going to talk about. I would write this in your planner, not your planner, in your notebook, and then we'll do some examples underneath that, okay? So how to convert a decimal to a fraction. And then don't write anything else yet, because I'm going to do some other things first. Still didn't change it. To convert a decimal to a fraction. First, I'm going to go back. Oops, that's not what I wanted to do. I'm going to go, and I want to talk about just place value behind a decimal. What is this first place called, Henry? Tenths. If you cannot remember this, make sure you have this written down in your notebook. What's my next place value, Ryan? Hundredths. What's my next place value then? Counter. Yes. And then what's this one right here? Before. Oh my goodness. What's this one before? The ones. Don't forget that. The ones. Notice how behind the decimal there is no ones place. Okay? It just goes tenths, hundredths, thousands. And the difference between these place values and the place values that are before this one is what? This THS. Okay, so remember if you hear that sound, it's on the back side of that decimal place. Okay, so we're going to use this today too. Okay. Now, when you convert a decimal to a fraction, what you're going to do is you're just going to read this. What does that say? It says 9 tenths, right? Okay. So all I'm going to do is put 9 over 10, and I'm done. It's into a fraction already. 9 tenths. That's it. This one will be read as 75 hundredths. So guess what number this goes over? 100. But you have to also reduce. Don't forget about reducing because you have to reduce. Can I reduce this? What can I reduce by? I can reduce by what? 25. Could I reduce by 5? Yeah, it's just going to take me longer to get to my final answer. So if whatever you see, because I know a lot of people say, well, I can't think of the bigger numbers that can be reduced by. Start small. Say, can it be reduced by 2? Can I reduce by 3? Can I reduce by 4? 5? A lot of times you can instantly tell if things are reducible by 5 and 2. Because you can see that last number. So start small, and then if it takes you a while to reduce, that's okay, as long as you get it to that last thing. And if I reduce this the whole way, it should come to what, do you know? 3/4. That's pretty an easy one. Let's do a few more together. If I was going to say, write that in a fraction, what would my fraction be? First of all, read it to me. What does it say, Jasmine? 3/10. So 3/10, that's my fraction. Can I reduce it? No, that's it. That's it. Tell me how this is read, Cadence. 55 hundredths. So what is that going to look like in a fraction to begin with, Ryan? Sure, 55/100. Can I reduce? What can I reduce by? I can reduce by 5s. Let's start by 5s, okay, because that's easiest for us. 5 goes into 55. I think some of you write it like this, and that's fine. I think that's maybe how they taught you that last year, and that's fine. Do what you're used to. I know this is 11, and this is 20. Can I reduce any more? No, we're done. Okay. What about this guy? Tell me what that looks like in a fraction. Somebody I haven't heard from yet today. Kaylee. Yes, and that's written like this. 368 over what number then? 1,000. And can that be reduced? What can it be reduced by? 2. It can be reduced by 2. But I'm not going to do it right now because it could take us forever, and I want to make sure we get to other things. Okay? Is that all right? So, but make sure if it's your homework, you need to reduce. Any questions on how to take a decimal and turn it into a fraction? All you do is read it, and however it's read, that's how you write it. Okay? Questions on that? That's pretty simple. I kind of like that. Okay, so here's the next thing you need to write. To convert a fraction to a decimal. This is what some of us did those first two, I think, on that pretest, I think. You had to make these into decimals. To convert a fraction to a decimal. So remember when we said that a fraction has this bar? And what's that bar mean again? Divide. Did you know a fraction is just a division problem? Yeah, that's all it is. So here's the thing. When you divide, this is where a lot of people get confused. They aren't sure which one goes in the house. No, the top one always goes in the house. Did you get them both wrong? You got them right? That's pretty good. You must have guessed right. So the top one is always the one that goes in the house. Why is this? It's because this says 3 divided by 8. So that means we're going to divide 3. So 3 is the one that goes into the house. 3 is the one that's going to be divided. Okay? So the top one always goes in the house. And then you start your division. So if I were you, the first thing I would do is I would put a decimal there. Where's a decimal after the 3? It should be right after, right? So I'm going to put a decimal right there. And I'm going to put it right up here, right away. Does 8 go into 3? No. Minus 3, minus 3. Okay. Does 8 go into 30? How many times, Ryan? 3. You're right. Okay. 8 times 3 is 24. Does this all look familiar to you? Long division, does it look familiar to you? Okay. Some of you know how to do short division. Does anybody use short division in here? That's fine, as long as you know what you're doing. Okay? If you're getting stuck, go back to the long way, because some of you know a different way, and that's fine. So I'm going to subtract, let's see, yada, yada, yada. I get 6, and I'm going to bring down another 0. Does 8 go into 60? How many times? 7? Wow. Come on, minus 56. I get 4. I'm going to bring down another 0. Whoop. Does anybody make those arrows? Some people do and some people don't. 8 goes into 40 5 times. Guess what? I move my thing down if I can get it. Come on. I'm going to have Mrs. Shook look at this thing. Okay. I'm minus 40. Guess what? I'm done. 3/8 is 0.375 in a decimal. I'm done. That's all I can do. The biggest thing is you're going to mess up in here. Take your time when you're doing your long division. I don't want you to mess up. Okay? A lot of times when you're dividing something by 8, you're going to come out with a nice answer. When you divide by 2, a lot of times you're going to come out with a nice answer. When you divide by 7 or 11 or 13 or any of those goofy primes, most likely your decimal is going to keep going on and on and on. Okay? So don't get frazzled if you're not coming up with something. Okay? Now, repeating decimals, this is kind of like what we talked about before, where you just keep going on and on. Repeating decimals, that's when a decimal comes up and it just goes on and on and on and on and it doesn't stop. And there's some kind of pattern to it. You've seen it on your calculator. Maybe it comes up 0.1818181818 or 777777777 or something like that. That's a repeating decimal, okay? And then a bar notation, this is what we use when something repeats. Because if something repeats and you get that as an answer on your paper, is it ever going to stop? It's never going to stop. Do you want to keep writing that number forever on your paper? No, you would run out of paper and literally you'd still be doing it. It would go on forever and ever and ever. And they make a bar notation. You probably heard of this last year a little bit. They make this bar notation so you don't have to keep writing that number forever. Okay? So bar notation, it shows which digits repeat. So let's say I do my division, and let's say I just made this up, I think, so don't think this is right. I just made it up. Let's say I do some division problem, and I come out to be this. It comes up 0.1818181818181818 or 19819 or whatever it is. I'm going to use that bar notation to show that it repeats. And it only goes over what repeats. And we'll do some practice with this in a second so we can have some examples in your notebook. I'm going to flip this page to see what I got on the next page, because I might want to add a page. Yeah, I want to add a page quick. All right, so let's say you come up with an answer that looks like this. What numbers repeat up there? Cadence. 1 and 7. So where am I going to put my bar over? 1 and 7. Okay? And then you can just write your answer like this. You don't have to write anything else. That bar notation tells me it keeps going on forever. You don't have to write anything else. What if I have something that looks like this? What repeats? So what number am I only going to put that bar over? 6. So you can write your answer like this then. Okay. What if I get this answer and I say, oh, okay. Why is this not the same thing, Jasmine? There's not another 3. If I write it like this, then the answer looks like this. 2 is different things, aren't they? So you only put it over what repeats. That's it. Even if I have something like this. What's that? If it was like this, Merrick, I'm only going to put over the 6 because the 6 is the only thing that repeats. If I come up with the answer like this, then I'm going to also put it over the 3 because that also repeats. You see how that also repeats? Okay. If I have something like this, 0.416, 16, 16, 16. What are the only things that repeat here? Zane? 1 and 6. So what are the only thing I'm going to put my bar over? That 1 and 6. So then I can write it like this. Okay. If I would also put it over that 4, this is what tells me what happens. That's not the same thing, is it? So you have to make sure you only put it over what repeats. Do you have any questions on that? Sometimes if you do it on your calculator, and I'm just going to show you quick, I'm going to divide something. It's going to come up to be a decimal, and it's going to be repeating. Let's see, I'll do, okay, 4 divided by 9. Let's do 5 divided by 9. Okay, so I did 5 divided by 9 on my calculator, and on my calculator it comes up with all 5s, and at the end it has a 6. Can you see that? See that? Okay. Do you know why that happens? It rounds it up. Because you got to remember, on your calculator, it only has that many spaces. So that's why it rounds it up. So I don't want you to get confused someday if you do it in your calculator and say, oh my gosh, it goes 5, 5, 5, 5, 5, 5, 5, then there's a 6 at the end. Why does it do that? It's just because the calculator rounds up. So don't think that it stops. It doesn't stop. Your calculator just doesn't go on forever, right? Like your paper doesn't go on forever, so I had to do something with that end one. So don't get confused if your calculator says that either. And you don't even need to use your calculator, so don't worry about it. So then, terminating decimal, that's another vocab word you probably need to know. But you really don't need to write too much down about this because you deal with terminating decimals all the time. Terminating decimals stop. They end. There's really no repeating going on. They stop. If you think of the word terminate, terminator, or if they have like, let's see, cable service or a cell phone, they say, well, we're going to terminate your service. That means they're going to end it. So that's the same thing here. Terminating decimal, it's a decimal that ends. It doesn't stop. It doesn't keep going on. And that's what, like the first one we did, that's what this would be. So we have terminating decimals that stop and repeating decimals that go on and on. Can there be decimals that go on and have no rhyme or reason? Like it can be 0.469321057. Can we have something like that too? Yeah, we can have something like that too. And they're just not terminating and they're not repeating. They're just called a rational number. So, an irrational number. So, we'll talk about that later. All right, convert fractions to a decimal. Decide if they will terminate or repeat. Okay. So let's look at these. What do you think? 5 over 33. If I convert these to a fraction, or decimal, how would I start to do it? What would I start to do, Cadence? Yep. 33. Let's just look at this. What do you think? Do you think it's going to terminate or repeat? You think it's going to stop or it's going to keep going? Why do you think that? 33 is kind of a weird number, isn't it? Should we see? And we'll save ourselves some time. Okay, so who thinks it's going to repeat? Who thinks it's going to stop? All right, 5 divided by 33. Oh, you want to know what the answer is? Good job. What do you think about over here? What do you think is going to happen there? 13 over 16. What do you think is going to happen? Think it's going to stop? It does stop. There's actually a way. If you just look at that number on the bottom, there's actually a way to know if it terminates or repeats or not. And it has to do with the factors. No, it has to do with the factors. You know what factors are? Like if you did you do like a factor tree or like the factor cake? Some of you did like the cake last year. You done both of them? Yep. If you would find the factors of those, I think if it doesn't have a 2 or a 5 in it, it's going to repeat. There's some kind of rule that if it doesn't have a 2 or 5 in the thing, it repeats. So that's even if you look like 9, the factors of 9 are 3. Anything you divide by 9, like 1/9, repeat. 2 over 9 is going to repeat. 3 over 9 is going to repeat. Even 7, I think. 5 over 7, let's see. No, that one's just a goofy one. That goes on forever. But yeah, there's a way to look at it and know if they terminate or repeat. I'm not going to make you know it, but just kind of have an idea of, okay, if this is an odd-looking number, most likely it's going to repeat. So, all right. That is all I have for you today, but let's look at your homework because I want to do some explaining about your homework today, okay?